I'm going to go through three studies and talk about why the population stratification should be an ongoing concern, and the ultimately, what we've known in social science for a long time is one of the ways to deal with confounding is to use within family models, and that's how I think we should go forward. So I'm going to start with something I thought would have been talked about already by this point, which is a very popular method now, Gremmel, which basically, instead of the genetic risk score, takes markers and looks at a sum total of the correlation in my markers with another individual's, unrelated individual's markers to get basically a score of our gametic correlations, summation of our gametic correlation. Basically, how similar genetically are Philip and I versus David and I, and then regresses that, or uses that maximum likelihood actually, against our phenotypic distance. And this doesn't suffer from the measurement error problem that the genetic risk score does, but it goes back and gives us a heritability estimate, and which we may or may not find useful if we're Arthur Goldberger or somebody else. So, but this has been increasingly used. It's used in several of your papers, or that I'm on as well. So, so the original paper that did it, there's two original papers. One looked at schizophrenia and one looked at height. This is the height paper. Even though that looks like a flat line, actually it's not. And they were able to basically reproduce. They got a heritability for height of 0.5 as opposed to 0.8, close enough, and they do some calculations about measurement error, and they can figure that they can get it up to 0.8. But I wanted to talk about the key identifying assumption, which is that among individuals who are unrelated, environmental factors are uncorrelated with the differences in their degree of genetic similarity, which itself results from random differences in the recombination and segregation of alleles. So in other words, the fact that I have a 1% genetic similarity to Philip, and I have only a 0.5% with David, which is the difference we're identifying off of, is uncorrelated with any environmental similarity or difference, and in fact results only from just chance. That in recombination, I ended up closer to Philip than I did to David. So to support this claim, in the original paper, Peter Vischer's group reported the correlation matrix of the chromosomal specific relatedness. So you could just do this now for chromosome 8 for Philip and I, and for David and I. And that result, if it is truly random, that result for chromosome 8 should be uncorrelated with our result for chromosome 16, right? If it's something about population stratification, then we're going to start to see a pattern. It's not really random because the chromosomes are segregating separately. Everyone follow me? So they do this. They show that, of course, there's some these are p-values that are less than 0.05, but they claim, Bonferroni corrected, nothing significant. But that's the wrong test, because my hypothesis is not that specifically chromosome 8 and chromosome 16 are related. My hypothesis is that there is some overall pattern in the data that suggests across chromosomes if I'm more related on one, I'm more related on the other. And then what you do is just plot this. It should be a uniform distribution, and you see a preponderance of small p-values. So it suggests that their assumption that is underlied this entire model that's now been replicated 1 million times, I don't know how many times, but a lot, is problematic. So I try a different approach, which is I use the HRS to look at something that if this assumption holds true, should display no heritability, should have no genetic basis, and that is something about your own childhood environment, the decisions of your parents. And that, in this case, was urban, whether you grew up in urban or rural area, and it doesn't matter whether we collapse suburban with the urban or collapse suburban with the rural, it comes out the same, and we find that it's highly heritable. Using the standard 2 PCs controls, we find that where you grew up as a child is heritable, has a genetic component, which doesn't make sense. using this method under their assumptions. If we go up to 10 PCs, we knock it in half. So there's obviously some ethnic, this is whites only, I should say, but still there's some ethnic stratification or geographic differences. And then we start to see declining rates of returns. We go up to 25 PCs, and we're really not knocking it out at all. So that's, to me, a big problem with using PCs. I'm at 25 PCs, and I can't get rid of this effect. So, and if you've seen PC, papers that look at geography of genetics, there's a classic paper by Novembre in Nature in 2009 that basically predicted where people were in Europe by 2 PCs. But then if one postdoc in Dorit's group, whose name I'm forgetting, did it just for the Netherlands, and you could see it's almost like a fractal. And I'm sure if you went in further, you'd see that you could sample within Holland or within Utrecht and find a spatial correlation too. So I think the problem with PCs is that there's never going to be enough, or maybe you're over controlling. So that's well, we do another exercises. We look at we do the traditional Gremmel analysis of height, BMI, and education, and we get lower estimates than Vischer did. But when we control for that very sloppy proxy variable of childhood environment, granted it's a very weak test, but we don't find any change, really, any meaningful change. Education goes down a bit. It's not significantly different, but it goes down from 17% heritability to 15% heritability. So that starts to raise some red flags, maybe, or some yellow flags, that when you go to things that, well, we shouldn't expect this to be that affected by childhood environment, but we should expect education to be affected by whether or not you grew up in an urban or a rural community. And that maybe not right now we're running every basically social science and some medical outcomes we can find in the HRS to see which ones may be sensitive to this violation and which not. So I think, but the fundamental assumption has been violated. So luckily there isn't a literature, also by Vischer's group with Sean Purcell, an approach that uses essentially the same approach but within families, uses sibling IBD to get which is a random flip of a coin, to get estimates of heritability, and finds the same 80% heritability for height. So I think, again, within family analysis is safer, better to be safe than sorry. You recognize this figure. This is your figure from the science paper showing the high polygenicity of educational attainment. Even when you go from marginally significant to all SNPs, you're increasing explanatory power. So Philip already mentioned that when you do this within families in the psych science paper with 3 different samples, it's still powerful. I didn't know you were going to show that, but this is the results from Framingham, and you see that unlike Gremmel, the genetic risk score is robust to this additional control of using within family, which I think should be at least a standard test always, at least hold out one family-based cohort where you can test the power of the score with using sibling fixed effects or controls for parental genotype or something that you're really creating a transmission disequilibrium test in the genetic thing. So the last thing I want to talk about is this modeling of VGWAS. So we've heard a lot about G by E. One approach that's growing in popularity is to basically do the agnostic fishing expedition like GWAS, but for what would be called phenotypic stabilizers, or potential sources of either G by G interactions or G by E interactions. And that is genes, or loci, I should say, that are associated with not the mean level of some outcome like they did in the educational analysis, but in the variability in that locus, in that phenotype. And so, again, Peter Vischer's group published a paper in Nature a couple of years ago where they did this using the giant consortium data, which was for height and BMI, and they found this this is for variability. So it's their outcome is the squared z-score value. And they found, lo and behold, that FTO was this highly significant gene on variability. Well, that should raise some red flags because that's also the most known powerful gene on average levels. And I don't have time to go into the whole critique of their methodology, but needless to say, if you're just using this pool, I mean, I totally admire everything you guys are doing. I acknowledge the importance of sample size, but I think that in our, in the medical geneticists went that route too, and used to do stuff based on pedigree studies where they used within family discordance and so forth to infer what genes must be driving certain disease states. And then the GWAS kind of threw that out the door in order to get large N's, and in throwing that out the door kind of introduced a whole other set of problems of confounding and of how would you, if you're just pooling data from individuals and across all these studies, there's no real way to separate out the mean effects and the variance effects. So I'm going to argue that we should also do this kind of work with family-based analysis. So again, I don't have the kind of N that Vischer has, but instead, another way to think about looking for variability is to do it within family. So we did an analysis where we took sibling standard deviation in height and in BMI and run GWAS on that. And the benefit of that is that you can control for parental genotype if you have the data with the parental genotype, like you do in Minnesota, for example, and then you can treat the genotype assignment as random assignment at conception, even without sibling fixed effects. You can also do it with sibling fixed effects if you have if you have more than two siblings, so you can compare pairs to each other. But here, we found some decent, nothing was genome-wide significant. We found a couple decent signals that were suggestive, nothing replicated. The only thing we replicated was a pathway that we were able to replicate in 2 data sets. But I think I'm starting from square one with 1 or 2 data sets, and really we should also be thinking about, or SSGAC should be thinking about consortia that are specifically devoted to, that have family data that can answer these kind of questions and do this kind of thing. Because it turns out also I couldn't replicate the FTO variability finding either. So, one other thing is that this approach, if you use within family variation, you can distinguish between nonlinear effects on mean level from true variance effects. And how do you do that is that you compare those cases where there's 2 of the minor alleles. So in the case of 4 siblings, right? 2 siblings. The sibling set can have 0 to 4 of the minor alleles. So if they have 2, the set has 2. That can be that you have 2 homozygotes, 1 homozygote for the major allele and 1 homozygote for the minor allele, or it could be that you have 2 heterozygotes where they each have 1. And there you can just simply compare the mean level for that set of those 2 cases and see if there's just basically dominance driving this, because you would get, if you had a nonlinear effect, if you had dominance or recessivity going on, then you would get an apparent variance inflating effect of an allele when it's really just a nonlinear effect on the average. So that's another benefit that you can't do when you just pool 100,000 cases that have no family structure or no comparability. So I just want to say that the focus has been on adequate sample size, but at the expense of confounding. And Greml, I think that at the very least, everyone who's doing Greml going forward should do some sort of placebo test on purely environmental variables and seeing what's going on, or control for relevant environmental variables for their particular social science or medical outcome. As I mentioned, there's no way to untangle the mean and variation effects in typical V GWAS, which means variation GWAS. And if we use the family-based approach, we really get randomization that applied economists love, and you can also disentangle more easily mean and variance effects. And the variance effects, I should say, I think are really substantively important, because we talked about what is the use of all of this for economics or social policy, and it's the alleles that show plasticity, show variance that we might be more interested in, rather than in terms of the average effect. If we redid the GWAS for education and looked at variance, then we might say, okay, these are the alleles that lead to high variability in education. These are going to be the people that are going to be responsive to the peri-preschool intervention or whatever intervention that we want, rather than it being just this affects the mean level. And I think that's going to be an important way that we go forward as social scientists who are concerned about policy interventions, to look for the latent plasticity in the genome. Drug companies are already doing this. They want they want to find the most plastic people, so that they'll be most responsive to the drug. I've read that they're doing pre-screening based on not this methodology, but on they do, like, for example, false pre-tests where they give placebos to everybody. They get rid of the placebos. They also do other, they look for high individual variability so that they'll have a response to the drug. So they're going to be doing it. I think we should be thinking about it as well, as we look to integrate the genetic information with the social science stuff. That's it.
We're moving more and more towards single SID families, right?
That's true.
And so there seems to be an enormous selection going on. I mean, it's using more educated people and so forth, having one child or no children whatsoever. So the question would be what the implication would be for the kind of study design we're talking about. And then what would you do with 10-child families? So if they go 2, 3, 4, I don't want to assume the family size itself is random with respect to maybe some of these same genetic factors. So you probably thought about this. I'm just curious.
I think that that the days of sibling fixed effects may be over at some point when we all have 1 or 0, but you still have monozygotic. Dizygotic twins to work off of when they come out by accident. But I would say exactly right that there are different populations. The ones that have 7 kids and have 2 kids. At the very least, it would be nice to, even if you're going to run something as a regular bread and butter model with no controls for family background, then run it on the only children and then run it on each, and see if that seems to affect the variance. I mean, it's very possible that the same genes that are under selection for education are also affecting the fertility. So that's an important complicating factor. And in fact, in contrast to the Gregory Clark story, I guess we're making ourselves stupider today if his thesis is right about industrial revolution, is we have the negative correlation between education and family size. So, but I don't know any social scientists that are really exploring that on a genetic, evolutionary level right now. Matt?
This is really interesting. If I'm understanding right, and it might not be, so you'll correct me. So you're looking at the variance as a function of the genotype, 0, 1, 2.
Exactly.
Do it over the genome. But you could use monozygotic twins, it seems to me, and the advantage of monozygotic twins is multifold. It addresses your concern, because monozygotic twinning is a random event. Dizygotic twinning is not, but monozygotic is. And what's more, it gets around the GG versus GE you're talking
Exactly.
about.
I've done that.
Would have to be
In fact, I've done that with your data with Chris.
Yeah. Oh, you have already done that?
Yes.
Oh, okay, good.
So I think
Did you find anything?
No.
Yeah, we only have 1,100 pairs of monozygotic twins.
That's the problem.
But
I think I think that thank God for twins. They're nature's gift to scientists.
But you should be able to get a reasonable.
that's a way to, I mean, because there's a huge debate about whether or not variability is a result of gene-gene interaction versus gene-GE interaction, and that's the way to separate it out, is use and to find out if I find a significant hit, whether or not it's a phenotypic buffer, environmental buffer, or it's actually internally a phenotypic capacitor of other cryptic genetic variation. I don't know who gave the paper, pre-reading paper on the corn oil, but that was really...
So maybe I could make a remark, which is that one question that came up during the previous discussion was that we might be over-controlling by including even 4 PCs, and now Dalton is advocating only using the within-family variation, which forces a pretty modest share of the total genetic variation. In practice, what we did in the study was something in between. I think the right way to use families, I mean, it's very easy to show. You can do the power calculations. You wouldn't be able to do a well-powered GWAS just within family variation at present. But I do think the one thing that you can do, and that Dalton did, and that we also reported in the original paper, partly with Matt's data, is that you can, conditional on having a bunch of results, you can then ask, do they predict the within family? So you can sort of use these siblings as a sort of robustness and sanity check. I think realistically that's what we can do at the moment, to the extent that we can sort of influence what sort of data that get gathered in the future. I think adding siblings is a very good idea.
Question. This is probably a stupid question. I'm not sure I understood what your point was with Gremmel. So you found a heritability for like urban child, or whether you were raised in a city, and so that it's implied that that's a problem with the method, or
yes. I've also found it for both fathers and mothers' education. So that's suggesting that folks who are more similar genetically, unrelated individuals, are more similar genetically, are also more similar on the environments they grew up with, and now on 3 different measures, at least for education. We certainly, parental education, as social scientists, we think is one of the most important measurable background variables. Now that, that could be, it could be genetic.
So that's a question.
Urbanicity can't be.
Sorry?
Urbanicity can't be explained by the draw that the child got in the genetic lottery.
Right. No. Parents might not.
No. So the whole point of Gremmel is supposed to break the linkage between the generations by relying on the random. The fact that it's not because you and I are 8th cousins that we're more similar. It's because of the randomness of the draw of. And that's violated. It could be robust to that violation, but it's showing that it's violated. I guess what I'm saying.
I mean, another way to think about your finding is even the original paper showed that at sort of higher relatedness thresholds, this assumption is violated. So maybe the correct way to think about this is that if you get sufficiently close to 0 when you set this, maybe for these sorts of traits we should use really conservative relatedness thresholds. I don't know what threshold you used.
We used the standard 0.025
and does it
correlation,
change?
but we tested it at 0.01 and it's still a problem. So we tried it with the extra PCs, lower threshold doesn't solve the problem. So again, it may not be a big problem, but it's just at least something that we give such careful consideration to sort of specification in other realms. We should think about it in this context as well.
Did you try partitioning heritability among all 22 chromosomes? Because if there's powerful population stratification, the estimated contribution to H-squared SNP by each chromosome in a chromosome analysis should differ substantially from its estimated contribution when different GRMs are formed for each chromosome, and they are analyzed jointly.
I didn't do that yet. That's a great idea.
Yeah, I was about to say, because one of the most compelling things I thought in the original Yang and Bishop paper was the fact that they showed that the length of the chromosome basically correlated with the amount of variation explained, with a couple of wacky side notes, like the one that had FDO on it was higher, which is not surprising. But of course, that doesn't take away from what you found. It's sort of, you're just saying that there's basically a biasing effect in addition to that potentially that has to be corrected for.
Yeah.
I mean, my basic, off the top of my head thought, without thinking more about it, is that that if the estimated contributions of heritability of each chromosome do not differ substantially, whether the GRM is computed for that one chromosome and then you just run that analysis by itself, or whether you run the 22 GRMs jointly, then this problem you could probably just dismiss.
So this may be naive because coming from this, at this as an outsider. So one thing that sort of struck me in a number of talks today, and I'm just going to address it to you now because you're the last speaker, is that sort of we're toying around whether we're interested in causal effects or if we're just interested in contributions to correlations and stuff. With your talk, Dalton, it seemed fairly clear that you're interested in causal effects because you're using notions such as confounding and impact and stuff. So now there seems to be a twofold game going on in many of the talks, right? One is to say, oh, these are really small effects and I can make them disappear entirely by little adjustments, right? But then there's also some pushback and saying, okay, so now we make a constructive contribution. And your suggestion was a family study to sort of unearth a causal signal in the data after all. Now, if these are all such sort of small effects, then small violations in the identifying assumptions would be potentially harmful. So what I'm to get to my point. What I'm surprised about is that we've heard very little about formal sensitivity analysis today, right? Like we have all these models, and we assume that they hold, and then we spit out data, but there's little sort of putting different distributions on the unknown parameters, then just futzing around with it a little bit and seeing what happens. That's point one. Point two specifically.
Model averaging.
Model averaging right there. So point two with the family effect. So I mean, I get the allure of family fixed effects, and Lord knows I'm gonna offer just that tomorrow as a solution as well. But without knowing the specifics of what you've done, I mean, sort of usually one of the assumptions in there is that this is truly a family fixed effect. That is, the parents treat both kids the same way, and
I mean,
depending exactly on how you run your, what you mean by family fixed effect, it may matter that even with these monozygotic twins, one is daddy's favorite.
That's true. I mean, the assumption, I guess, then is that assuming that something like education or even BMI goes through, it's not just a purely, internal process of the biology of it that actually goes through behavior, right, which we would all assume that's the case, and social interaction, that the social interaction affects, differential treatment effects by the, let's say by the genetic risk score for education, by parents, isn't substantially different than the social treatment effect when you compare individuals across families. So in other words, it could be the case that if I show precociousness or ask a lot of questions in society, I get treated one way, and inside my family, I get treated another way. In that case, the mechanism would be very different, and you would get a different result. But if it's, if we think that the teacher reacts to the kid who asks the questions, a lot of questions because of some neurological thing, the same way, or at least in the same direction, in similar magnitude, order of magnitude as the parents do, then I think we're on safe ground using this back and forth strategy for testing the robustness of the or confounding of the score. I don't know if that answers your question, but that's the assumption. Sure.
I don't think there are.
Sorry. So like in your previous work, when you were talking about instruments, you were very concerned about, as yet undiscovered pleiotropic effects, and I think rightly so. Are you similarly concerned about violations of assumptions in the family models, as yet undiscovered? And should you be?
I should always be, yes, but but I mean, for example, in earlier work on birth weight, in monozygotic twins, birth weight differences I treated as a random event. However, once you start going far away from birth, you don't know what the pathways or mechanisms are. So I've had arguments with Jerry Behrman and other people that you cannot use even twin differences in birth weight as an instrument for anything, because he tries to use it for instrument for schooling on wages, and that's because it's obviously affecting things like your non-cognitive skills and your cognitive skills, and so far the exclusion restriction is violated. So I think that's the same kind of thing here, that you have to think about. I wouldn't go ahead and just because I have a within family model use the genetic score as an instrument, if that's what you're asking at. Right now I'm just trying to see if I'm doing reduced form modeling just to say, is there any effect whatsoever of this random assignment at conception?
So, if I could just add,
you want to bail me out here?
I don't think the way to think about these effects is as reduced form effects, and there is no assumption that they are invariant across environments, or that they don't operate by evoking a particular environmental reaction from a parent. So that's still a causal effect. There's a causal pathway from the particular genetic draw the child got in the lottery to whatever outcome you're interested in. That's potentially testable in our data, but there's no claim, and there's no claim on our part that these are some sort of structural relationships that can't be modified by environmental factors. And in fact, very often, it wouldn't surprise me in the least if indeed these genes are affecting outcomes through genetic pathways, environmental pathways.
I mean, I would say as someone who was raised originally as a molecular cellular biologist, I mean, if you ask a cellular biologist, are there G or G by G effects, mostly they say no. Those don't exist.
G by G, they'll talk about in a second. Epistasis is
well, I mean, I'm thinking independent of environment. Right? Everything operates through the environmental structure. And, well, that's what
G by G, epistasis, that fact that you have.
So what I would say, the guys I hang out with would say, is that everything operates by inclusion of environmental variation. That this is the simplest structure of a dendritic arbor.
Yeah.
Has to do with environmental, the light-dark variance that particular animal encounters.
Yes.
Now, we might all encounter similar environmental variance, so that we might all have the same dendritic structure. But if you create an artificial environment where that's not true, everything changes. So, I mean, I think that the intuition is everything works through interaction with the environment.
Yes.
I may have said that badly in the beginning, but that's the point I want to make.
Yes, and this was always my frustration with the terms that are used in twin models, evocative environmental effects, active and passive environmental effects. I mean, they do conform to some sort of intuitive notions that we have, but they're rarely defined in a way that that are very precise. So it's rarely the case that I can point to something and these things, as far as I can tell, have never been defined in a really rigorous way. Maybe what they're trying to get at is the fact that sometimes these environmental pathways are modifiable, in which case we say that the genetic effects operate through environment, and sometimes it's not. The problem with that definition is that then the environment is whether or not something is environmental is going to depend on the range of technology. So that's going to vary depending on the cohort you're studying.
But I think we're actually talking about separate things, right? So if I understand you correctly, you're saying so when you say that you don't talk about structural effect, it sounds like you mean there's no sort of invariant effect across. Okay, good. So let's grant effect heterogeneity like we usually do in the social sciences, right? Nonetheless, if you're saying you're interested in reduced form, well, the reduced form, again, naively, seems interesting only in as much as it's sort of proportional to the underlying causal effect. But if you have these confounding things going on, there's like if your quote unquote treatment is confounded, say it's through population stratification, and there's no guarantee that you're
that's different, yeah.
Okay,
so if it's just that the allele is correlated with some confounding variable, that's one thing. If the allele is influencing the outcome, which it did in your example, through an environmental pathway, then that's an interesting thing about the world that we should be trying to learn about.
Can can I ask you a question? I mean, again, some people commenting about what they heard throughout the day. Everything seems very static. I mean, people are talking about dynamics, and all people talk about development. So you would think there might be an interesting question about wind. At what stage in the life cycle do you find these heritabilities, and to what extent these things crystallize and become? I'm asking, what's the state of the literature on exactly that? Heritabilities at age, on behavior at age 8 versus age 80 or something. Well, I know, but I mean, the question is looking at the dynamic manifestation of the gene. In other words, there's the context there, but to what extent is the gene being modified at different ages? I'm just asking a simple factual question. Heritabilities at age, at age 45 versus age 25.
Do you mean for particular genes or the quantitative characteristics?
Well, particular genes, but then overall.
Well, I think we know very little about particular genes.
But overall,
With respect to overall quantitative capability, we know a decent amount about it with respect to something like cognitive ability, and we're getting there a little bit with antisocial behavior, it seems to show similar pattern of increasing variability with age. And that's sort of getting to be a general idea. But you have to remember when it goes in between models, and we don't have a lot of specific data on like age 45 but you have to remember what goes into between models, and that is the social, the genetic and environmental influences and independence. And what's really going on is people are selecting through genetic influences and responding before them with respect to the environment.
Like Professor Niederhauser's model and putting it dynamically. So if you took that model and put time substrates, that's what I'm asking. Have you done that?
Well,
We're
what happens?
we need money to do that, but that's the plan.
No, but I mean, it's a plan, but it hasn't been executed.
No, nobody has data like that yet.
Okay.
And the problem is that that model relies on the assumption that genetic and environmental influences are independent. If what's actually going on is we pay people increasingly their genetic, environmental, and genetic as well as environmental influences are increasingly selecting environments that reinforce their genetic influences.
Right.
Over time, what's happening is that the environmental influences are getting it's a gene-environment correlation. After the gene-environment correlation gets thrown into the heritability. So the heritability estimates are increasingly biased high if you want to look at it that way.
Right.
Now, Matt's comment earlier today was that a lot of geneticists will accept as part of what should be in heritability that is active gene-environment correlational influences are considered part of the heritability estimate, but that's really begging the question of how these interchanges that what happens as people select increasing environmental, comfortable, or whatever situations that reinforce those genetic influences. It just means that there's something.
I mean, actually, I thought that from the NAS twin sample, didn't people like that look at some of the stuff longitudinally? But again, it was a cognition.
They look for memory.
It's just memory, right? And then there they found, age-related changes, right? It's like, recall it like 5 years.
Yeah, that's.
And so, yeah.
But it's the exception. The other studies don't mind. So there are other
Well,
studies.
they don't.
Yeah, it varies. Yeah, there are not a lot of studies.
But that's a big twin sample.
Yeah.
Yeah.
But I mean, part of the difficulty is, again, finding big enough, and the right twin sample being the right, so. And you're right, and some of the correlations, and obviously there's an eye to do rocket correlations, but things like height, I'm not so sure that you make that argument.
Right, or at least it's.
But those level off at 18 too, so it's like they
Exactly,
should.
yeah.
I mean, but you're right. I mean, there is more work that needs to be done on some of this. The difficulty is that the models you need, and most of them I think could be family twin type models, I think, at least right now.
There are some examples of specific genetic variants where the genetic effect increases with age.
Sure.
The best example is AODH2,
Right.
where
Yeah,
its effect on drinking is pretty minimal in adolescence, but increases as you get older. So,
Yeah,
So there are some.
Have people done like a mediation analysis for that? What are the mechanisms that influence the, I mean, that's a natural candidate. So you
Yeah, it's
observe
a-
lifetime mediation.
Well, it is. I mean, it needs exposure.
No, I would say that for sure they haven't done that, but I agree it would be, I mean, it's a nice model system, if nothing else. You kind of know at least what's going on. People get sick when they drink, so they drink less.
I mean, I have to say, I'm lost here a little bit because, I mean, you have two sort of giant vectors, right? You have the genome, which is at least an observable vector. And then you have the environment, which is a giant unobservable vector. And we can say, oh, well, we can kind of control for non-independence of the genome because we can measure it and see where the non-independence is and sort of reduce it to an independent object. And then we have this giant vector, which you're kind of taking the dot product with. What you want is to raise people in kind of white noise, right? You want to have people, you want to get an independent environment vector.
Well, that would be ideal, that you could tell, there are a lot of chunks of the environment you measure, so you could condition it.
But don't you have to understand how it's going to interact with the genome?
Well, again, which part do you want to call exogenous and which is endogenous, I agree, but
Yeah, that's the problem.
everything's not going to be endogenous. If it is, good luck.
That's exactly where the president stuck.
Right.
Yes, and have been for
And a lot
20
of the
years.
Work people are contemplating doing like the National Child Study, are looking at really how to put brute force environmental toxins, essentially, lead, all these things. And that's good in the sense that unfortunately lead has a huge effect. You don't need much lead to create a pretty ginormous phenotype. But there's more to life than lead, fortunately. And lead exposure, and they're not measuring a lot of that stuff because they don't know how they didn't know which ones, and you need them. I mean, that study's already ridiculously expensive, and then just
I
can't.
mean, this is, with Jim, I think you nailed it. It's like, what's endogenous, what's exogenous, and how do you solve that problem?
That's where we can help.
Yeah.
That's our contribution to all of this.
But you never solve the problem, you think about the problem.
Yeah.
You postulate certain mechanisms and test them. I don't know what else you can do.
Yeah.
I don't think there's a general solution saying, I now pronounce this data set exogenous.
Wave the magic wand.
But I mean, but wasn't that the purpose of these models though, these dynamic models? I guess Steve is gonna show this tomorrow, right? You're gonna show a dynamic manifestation of a model, of genetic pathways, right?
Yeah.
But I mean, that's just a general question.
So could I suggest that we take a coffee break, and would people mind sitting around so we can talk some more until the bus arrives?
That's great, Dan.
Okay, first of all, let me thank Matt.